and then it generates a set of ranges for each shard. So it actually ends up quadrupling the number of ranges that you produce because it prefixes all of them with the shard index. Say if you have 4, and then so it'll do 4 times the amount of queries, but it'll distribute those queries better. So that's like sort of the thing you have to play with, of like how much do you not want to hotspot and how much you how much you want to utilize your cluster. And we've been finding, I actually don't want to. I think that it's better not to shard for smaller queries that have to return lower result sets and are smaller like bounding boxes, but I have to perform more tests and currently.
Yeah, I get lost in this too. It's tough. This is the hard part, right?
Yeah.
So just to rephrase so I understand, in one sense, you're first doing a query that points to its right shard, and then on the shard it does another?
So it's all one query, but the range, so on the client side, the range decomposition happens, and now we have like a sequence of long, or actually like byte array ranges, like this ID, and then we just take those and map over those and flat map over those, and then turn those into, we say this range, actually do this for like 1 underscore this range, and 2 underscore this range, and 3 underscore this range. So now we're doing twice as many queries, but the queries all happen all at once. They are just now containing shard information for each shard. And that's similar to the periodicity, right? Because if it's over 2 years, then we have to do this space-filling curve query for this year and this year at the same time.
Thanks for the very nice presentation. Different space filling curves have very different location preserving characteristics. Any performance studies evaluating these characteristics against all the data types?
There is actually so GeoWave is a collaborative project by the NGA, Radiant Blue, and Booz Hamilton. And they did, for preliminary like choosing the Hilbert curve, they did this whole benchmarking study about, they had like 3 different characteristics of how they measured locality, and then measured the quality of various space-filling curves. So I'd recommend like looking for that. Actually, Rich Fetcher has a presentation at FOSS4G North America in 2016 that kind of goes over that work, also a slide deck that you can look at. I don't know exactly where that research is, but they chose the Hilbert curve based on that sort of research. What I think that you need to take into account though is that they might be better ranges, but how long does it take to actually generate the ranges? Because that's going to affect your query performance. So that's a really important. The Z-curve stuff is just, it's not as good, but it's super quick to compute. It's like bit twiddling. So it's a real trade-off, and I'm not sure which situation it's better for. We're figuring that out.
It's really a case of you pick the curve that works best. Go again. Still on?
There's problems when you have all of the diversity cases.
Yes. Do you want to give Digital Globe some credit for GeoWave as well? They were a major contributor to that.
I apologize, I didn't know that. So Digital Globe, thank you. Also, Digital Globe contributed heavily to the initial geospatial Spark work, so also thank you for that. We miss you.
A couple of key points that may have been overlooked is that the primary reason we do a space filling curve is to take your n-dimensional query and turn it into a one-dimensional query. It's much easier to do an efficient search on a one-dimensional sorted space, which is what you end up with, than it is with n-dimensional space. Also, a nice thing about the way it's indexed is that the number of bits you use of the index gives you your zoom factor. The more bits, the further down in the curve you are. Fewer bits, the higher up you are. So a couple good points. It's also worth pointing out that this GeoWave uses OGC simple features well-known text encoding to stick the geometries into accumulo key value pairs.
Oh, they're on accumulo now?
Nice. It's well-known text, well-known binary. You can do it either way.
Cool.
They also use GeoAPI back down inside GeoTools, and there's a lot of other OGC standards buried in there which you may not know about. So
yeah, it's
good stuff.
It's hard to figure out exactly what Mr. Geo is doing, but I'd like to learn more. Yeah, that's a good point about the one-dimensional indexing. I think it solves a problem that I'm sorry, I forget your name. NASA guy was talking about, where he said big table is hard to do with geospatial queries because it's just, it's very confusing. So I'm hoping that like technique kind of maybe doesn't, at least gives you some thought about how you would actually do a big table storage of your REST or geospatial data, because that's what we're attempting to do. And if you've done any like research on that, we're actually like collaborating with NASA on a project. So I'd be interested to see how we're collaborating.
So, George?
I thought by now somebody would have said something about discrete global grids, but maybe I'm wrong. Oh, there it is. Go for it.
Chuck is using
All the way
his
over there.
credits for today.
Was there somebody else?
No, yeah, first.
So the whole idea behind a space filling curve is that you're going to take a space, you're going to tessellate it, and do a curve through it. So I don't think anyone has actually done a space filling curve on DGGS, but
Yes, I have.
you have. Excellent.
Oh, yeah.
There you go.
Thought this would have come up on the Landsat discussion.
Yeah. Well, what you've shown is really encouraging from where I see it. It looks like you've gone probably about 2/3 of the way along encoding mechanisms to construct discrete global grids without moving away from the Cartesian XYZ space. What discrete global grid systems sort of do is take that space and actually translate that to the curved surface of the Earth.
Nice.
But one of the key features of and value proposition of DGGS, which you're a good spokesman for, is by using space filling curves as an indexing mechanism, it allows you to take these sort of complex, multi-dimensional, multimodal queries and turn them into one-dimensional space. So I'd be really interested to touch base with you.
Yeah, that'd be awesome.
On the sides, yeah.
Absolutely, yeah, and I think that just to wrap it to the original point that I made about like there's these other big data technologies that we want to take advantage of really badly, but we live in this multi-dimensional space of geospatial, spatiotemporal. So doing that translation of here's my three-dimensional stuff, I'm going to turn it into one-dimensional stuff, allows us to like support all this back end. So it's pretty exciting.
Yeah. Ready?
Oh, let's see. Perfect. Very good.
Okay, thank you. So, I guess we are done with time, and
Oops. Thank you.
it's coming, and here it is, yes. Thank you. Okay. Peter in stereo. So, we had great talks, we had great discussion here. Thank you all for participating so actively, and thanks again to our three speakers for the open source world and for projects from LocationTech, and talking about agency perspectives on LiDAR and raster data, and talking about what databases can contribute. I hope that's good food for lunch to talk on, and see you again at
So
George,
we're
what
at
time?
lunch. Lunch is on your own if you didn't know that already. We will start at 1 o'clock, so find a quick place and come on back. Good stuff.
Okay, see you again at 1 o'clock.
I've already laughed at this guy for the piece.
I'm much smarter than you. Yes, yes. That's right.
Yeah, I think.
Wanna go grab lunch?
Well, it's not like
That would be hard to do. Figure out where to go. We do want to get like the well, yeah. Next month of big data. So it's kind of early days trying to understand it. What Chris I never met. How much have we talked? I feel like there are examples somehow it's just not like you think.
Very similar. So do you, is it going to be okay to just dump that on the shop?
I've got it. In fact, it's on the stick, so now I can load it.
Collaborating with that, and how does this map to the grid system, and how do we potentially implement that?
I was actually just going to pick up something. Well,
Yeah, we don't. Just to the actual district. We start with the discrete space, so how you map to your projection system space.
Oh my gosh. Oh my gosh. Actually, I've seen that video. I saw the
GGG's tessellation.
chives.
And almost plug and play without too much automation.
I figured it was.
Yeah, that's a really good project to talk about.
Well,
If it maps to a
yeah. Well,
that's what we actually work on.
Yeah.
So we have like tiles that map to like already have tile coordinates, and then so GeoWave and GMS will use a normalized like lat long.
So can we chart these? Plug them in over here?
Yeah, that's a great idea.
So it's all, there's different approaches to the quantization, but that way.
DGGS may give us
Does this just pop up?
less error.
Yes.
Another chance.
Yeah. Well, and that's how it works. So the public research. So yes, I mean the DGGs are actually tessellating the data of the ellipse surface model of the Earth. Once you
Put her back.
are easily sharded and we don't lock it into spaceman curves, but the best performing DGGSs all use spaceman curves as their indexes scheme. So once they're tessellated, it's how do you index that? Exactly. You just get sort of down. Then you just need you're just working with the indexes. So here's my indexes. This big on so many levels down. Here it is. I'm up higher in the tree, and you can start to do these sort of multimodal or multi-resolution sort of query operations, much like what you were showing on the screen. Except if you sort of curved what sort of your representation of that, you have pretty close to what
Polygon tessellation?
well, yeah, but see with the DGGS, the shape of the cell. This is where some of the inertia comes in. Is not critical to see. Okay, so with, it has to do with the fineness of your fit of your tessellation. So the hexagonal itself gives you the fineness of fit and sort of scale through. But you can equally have a train with a mesh or a electrical mesh that you do just based on the different polyhedral that you use to construct your tessellation. But
So that's actually just the last third, roughly, of the figures you were talking about.
exactly.
Right.
But all of the index, that allows you to then stop thinking about where is my what projection am I in? That's here's my block. And it doesn't matter whether you're dealing with a hexagon or a triangle or a square. It's a representation of an area in space. And so you start to sort of step away from sort of spatial arrangement and I've got to have everything aligned and all.
I don't have to worry about protection.